Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 7th class in linear programming chapter. In this class, we will do two problems. With that, all the exercise problems of 12.1 will be completed. This linear programming chapter is very easy if you understand this first exercise. As usual, we done these two problems stepwise. What is to be calculated in step 1, what is to be done in step 2, step 3, step 4, like that, all the things I explained in detail. To understand this, you please watch this video till the end. And it is important, you must have previous classes knowledge to understand this more clearly. Before going to start this video, please drop a like for this video and share it with your friends. Let's begin the class. While doing linear programming problems, when the feasible region is unbounded, then we use these 4 steps to solve linear programming problem. What is step 1? Identifying feasible region by using constraints is step 1. Step 2 is, after identifying feasible region, you need to find corner points from the feasible region. After finding corner points, step 3, you substitute these corner points in objective function to get corner point table. After getting corner point table, step 4. Step 4 we'll do only when the feasible region is unbounded. In step 1 only we'll calculate feasible region. When feasible region is unbounded, then only we'll do this step 4. In step 4, we'll graph z less than m or z greater than m. Here z means objective function. In the question, if they are asking minimize objective function, then we will graph z less than m. Z is objective function. M is the minimum value we will get from corner point table. If they are asking maximize in the question, then we graph z greater than m. Here z is the objective function. M is the maximum value that we will get in corner point table. You observe this question number 9. This is one of the interesting question in this exercise. You observe what they are asking, maximize. Maximize this linear function. This is objective function, right? We need to maximize this objective function by using these constraints. You can observe here, x greater than or equal to 3. That means to identify feasible region, I need to graph this inequality. Okay, so to graph this inequality, I will draw the line x equal to 3. Okay, so and we need to graph this inequality also. To graph this inequality, we will draw the line x plus y equal to 5. Okay. And we need to graph this inequality also. To graph this inequality, I need to draw the line x plus 2y equal to 6. Okay. X plus 2y equal to 6. Now, you see y greater than or equal to 0. Y greater than or equal to 0 means in first quadrant, second quadrant, y coordinate is greater than 0. This we will discuss after graphing all these constraints. You see here x equal to 3. We know that x equal to k is a straight line parallel to y axis. X equal to 3. Something you will get like this. So no need of any points on this line to draw this line. We can easily draw this line. Now to draw this line, we need 2 points on this line. For that, we know as usual, as we are in the 9th problem of this exercise, you know this, we'll consider a table like this. Now what I'll do, you put y0 in this. When you put y0, then you will get x equal to 5. You put x0, you put x0 in this equation, then you will get y equal to 5. So we know 2 points on this line. One is 5, 0, another one is 0, 5. We know 2 points on this line. So before going to draw this line x plus y equal to 5, I will find 2 points on this line x plus 2y equal to 6. Okay. For that, again you consider a table like this, x values, y values, right? You put y coordinate 0, put y0 in this. If you put y0 in this, you will get x equal to 6. You put x0 in this equation, 2y equal to 6, you will get y equal to 3. Now I know 2 points on this line, I know 2 points on this line. So we'll go to the graph. Now we'll draw this line x plus y equal to 5. So you mark the points 5, 0 on x-axis, 0, 5 on y-axis. You see, this is 5, 0, this is 0, 5. You draw a line passing through these 2 points. You can observe here, as they given greater than or equal to, we will draw normal line instead of dotted line. You observe this is 5, 0, 0, 5. I drawn a line passing through these 2 points. If you observe this line, for this line, this is origin side because origin is present here. And for this line, this side is non-origin side. As origin side, non-origin side are present for this line, I'll put 0, 0 in this inequality. You put 0, 0 in this inequality. In place of x, you write 0. In place of y, you write 0. What you will get? You will get 0 greater than or equal to 5. 0 greater than 5 is true or false? Actually, 0 is less than 5. So it is false. As you got false here, which side you will shade? See, if it is true, we will shade origin side. As it is false, we will shade non-origin side. You observe here, this is non-origin side. We need to shade this side. You observe this yellow color shaded part is there. That is the solution of this inequality x plus y greater than or equal to 5. You take any point in this region, you substitute here, it satisfies this inequality. This is solution of this inequality. So we graphed the inequality x plus y greater than or equal to 5. Now we graph this inequality x plus 2y greater than or equal to 6. For that we need 2 points on this line. We already calculated 2 points on this line 6, 0, 0, 3. You mark the points 6, 0, 0, 3. You see here, this is 6, 0, this is 0, 3. You draw a line passing through these 2 points, right? As they given greater than or equal to, we will draw a normal line instead of dotted line. So draw a line passing through these 2 points. You please observe, I drawn a line passing through 6, 0 and 0, 3. For this line, origin side present, non-origin side present. As this line contains origin side, non-origin side, I'll put 0, 0 in this inequality. You put 0, 0 in x plus 2y greater than or equal to 6. In place of x you write 0, in place of y you write 0. 0 greater than or equal to 6. That 0 greater than or equal to 6. Actually 0 is less than 6. That means it is false. As it is false, which side we need to shade? If it is true, then we will shade towards origin side. As it is false, we need to shade non-origin side of this line. So see, this is the solution of this second inequality. So you observe this part is there, this part. What is this? This is solution of this inequality. That means if we take any point in this shaded part, if we substitute in this inequality, it satisfies. Okay, now as we graphed these two inequalities, what is the common region satisfying both the inequalities? What is the common region satisfying both the inequalities? Please observe carefully. This is the common region. This is the common region satisfying both the inequalities. Okay. Now another two inequalities are also there. Now we will consider them. You come to this one now. X greater than or equal to 3. You know x equal to 3. X equal to 3 is a line parallel to y-axis. So we will draw a line parallel to y-axis at x equal to 3. You observe this is the line x equal to 3. Okay, so we need to graph this inequality na? X greater than or equal to 3. You observe this side all values are greater than 3, right? So it can be understood easily. This part is the solution of this inequality. In case if they given x less than 3, then left hand side part, this part is the solution. As they are given here x greater than or equal to 3. So this is the solution of this inequality. I am not shading the part, just you keep this in your mind. Now if you observe the common region formed with these three inequalities, where is the common region? Common region, please observe carefully please. Common region with these three inequalities. See, this is the common region. Y greater than or equal to 0. Y greater than or equal to 0 means this whole thing will come. But when we see the common region with all the things, this is the feasible region. I hope you are understanding. What is this? This is the feasible region. That means if we take any point in this feasible region that satisfies all the inequalities. You can observe here, this part is there, na? What is this part? This part is the feasible region. Is it a bounded feasible region or unbounded feasible region? We can easily understand that this is unbounded feasible region. As we are doing these problems stepwise, step 1 is identifying feasible region. So we identified feasible region. This is the feasible region, and we came to know that this feasible region is unbounded feasible region. Now, second point is we need to find the corner points. You observe this is one corner point, this is second corner point, this is third corner point for the feasible region. So this point we already know. What is this point? This point is 6, 0. This point and this point we need to find by solving respective line equations. This line equation is x plus y equal to 5. Solve these two lines. While solving, I'll use subtraction method. See here, these two will get cancelled. Y minus 2y is what? Y minus 2y is minus y. 5 minus 6 is minus 1. So you got y equal to 1. Now what you will do? Y equal to 1, you substitute in this equation, then you will get x. X plus 1 equal to 5. X equal to 4. So what is the point you got? You got the point x comma y. What is x comma y? X comma y is 4 comma 1. We got this point. This point is 4 comma 1. Now I need this point. You can observe here, this is point of intersection of this line and x plus y equal to 5. So you solve x equal to 3 and x plus y equal to 5. You put x equal to 3 in this equation, then what you will get? Y equal to 5 minus 3. That is y equal to 2. So you got the point x comma y. What is x comma y? X comma y is 3 comma 2. So we got this point. This point is 3 comma 2. This point also we calculated. What is this point? This point is 4 comma 1, and this point we already know, that is a 6 comma 0. Now we'll go with the corner point table. What are the corner points we got? One is 6 comma 0, another one is 4 comma 1, another one is 3 comma 2. Substitute these corner points. Substitute this point in this. What you will get? Z equal to minus 6. Substitute this point in this. What you will get? Minus 4 plus 2, that is minus 2. So you will get minus 2. When you substitute in my 3 comma 2 in this, you will get minus 3 plus 4, that is 1. Okay. As they are asking, maximize this objective function in the question. What is the maximum value in this corner point table? The maximum value is 1. This feasible region is bounded feasible region or unbounded feasible region. You can understand that this bounded region is unbounded feasible region. So as feasible region is bounded, we can declare here. As feasible region is unbounded, we need to write that step. As feasible region is unbounded, 1 is may or may not be the maximum value. 1 is may or may not be the maximum value. So to conclude 1 is maximum value or minimum value, we'll go with step 4. As they are asking maximize, we graph z greater than m. Z means objective function. Minus x plus 2y greater than 1. Z greater than m. We graph this inequality. To graph this inequality, first we need to find 2 points. We need to draw the line x plus 2y equal to 1. To find 2 points on this line, I'll go with this x value, y value. Put y0, x0. You put y0 in this, then what you will get? You will get x equal to minus 1. So one point we identified, that is minus 1 comma 0. Now you put x0 in this. If you put x0 in this, then you will get y equal to 1 by 2. To draw this line here, strictly greater than they given. As they given strictly greater than, we need to draw dotted line. So first you identify the points minus 1 comma 0, 0 comma 1 by 2 on this. This is you observe it, this is minus 1 comma 0. Another point is what? Another point is 0 comma 1 by 2. 0 comma 1 by 2 somewhere here, right? So you draw a dotted line passing through these 2 points. You observe here, we drawn a dotted line passing through minus 1 comma 0, 0 comma 1 by 2. And now you find the solution of this inequality. For this dotted line, origin side, non-origin side present. Yes, this is the origin side of this dotted line. This is non-origin side of this dotted line. You put 0 comma 0. You put 0 comma 0 in minus x plus 2y greater than 1. Then what you will get? 0 greater than 1. 0 greater than 1 is true or false? 0 greater than 1 is false. So which side we need to shade? We need to shade non-origin side. You observe, this is what? This is non-origin side. If you observe this, I'm not shading this. If you observe this, this is the solution of z greater than m. Is there any part common with feasible region? As this is the solution of z greater than m, you can observe this area. There is a solution common with the feasible region. The solution of z greater than m and feasible region have some part in common. This is not happened till now, whatever the problems we did in this exercise, right? So we'll write the same thing. Solution of minus x plus 2y greater than 1, some points in common with feasible region. As the solution of z greater than m has some points in common with feasible region, we say that there is no maximum value for given objective function. Therefore, z equal to minus x plus 2y has no maximum value. Till now, whatever the problems we did, in that z greater than m has no point in common with feasible region. Then we say that from corner point table, 1 is the maximum value. But in this problem, there are points common with z greater than m and feasible region. If we got like this, there are some points in common with z greater than m and feasible region, then we say that there is no maximum value or no minimum value based on what they are asking. As they are asking maximum value of this, we say that no maximum value. I hope you understand solution of this problem. You observe this 10th question, last question in this exercise. Maximize this objective function z equal to x plus y subject to these constraints. Okay, so what I'll do to graph this inequality, we need the line x minus y equal to minus 1. So I calculated 2 points on this line. Now you observe, I'll mark these points. One is 0, 1, another one is minus 1, 0. Look here, 0, 1, minus 1, 0. As they are asking, as they given here less than or equal to, we'll draw a normal line passing through these 2 points. Okay, for this line, this side is origin side, this side is non-origin side. I'll put 0, 0 in this inequality. You can observe that we got 0 less than minus 1. Actually 0 is greater than minus 1. As we got 0 less than minus 1, it is false. If it is false, which side we will shade? Non-origin side we will shade. You please observe here, this side we need to shade. This is non-origin side. As they given x greater than or equal to 0, y greater than or equal to 0, at the end feasible region is in the first quadrant only. That's why this part we will get. Now we graph this inequality. Okay. So for that we need the line minus x plus y equal to 0. From this you will get y equal to x. This is of which form? This is of the form y equal to mx. As m is positive, this line is passing through origin. We know that y equal to mx is a line passing through origin. If m is positive, the line lies in first and third quadrant. You see here, this is of the form y equal to mx, m is positive. This line is passing through origin and which lies in first and third quadrant. So we drawn this line, no need separately 2 points on this line. As this line is passing through origin, we cannot put 0, 0 in this inequality to graph this inequality. What we do, we will find a point which is any one side of this line. You take a point which is any one side. You take a point here or you take a point this side, but make sure you take any one side of this line. Suppose I taken this point 1, 0. I know that where this point is this side of this line. I substitute this point in this inequality. If it is true, which side I taken point, that side only I'll shade. If it is false, other side I'll shade. I hope you are understanding. We already done this type of problems in earlier also. There I explained more clearly. Now what happened? I taken a point here and I substituted in this inequality. I got it is true. As I got it is true, which side I need to shade? Which side I taken the point, that side I need to shade. So this is the solution of this inequality. Okay. Now you observe, as they given x greater than or equal to y greater than or equal to 0, our solution will be in first quadrant only. So this is the solution of this inequality when we combined with this. Now if you observe the feasible region for this, You see, first one, see, if I take combination of this and this is the solution. If I take combination of this and this is the solution. What is the solution satisfying all the inequalities? There is no common region satisfying all the inequalities. That means there is no feasible region for this problem. You observe from figure, we can observe that there is no point common in two shaded regions. Thus, the problem has no feasible region and hence no feasible solution. No feasible solution means then we cannot go further. We say that no maximum value of z. I hope you understand solution of this problem. If you like this video, please drop a like and share it with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye bye.